Hello and welcome to Natural Language Processing course. A long-standing challenge within artificial intelligence has been to build intelligent machines, and a major part of intelligent behavior is understanding language. For many years, this goal has been seen as too difficult. However, as NLP technologies became more mature and robust methods for analyzing unrestricted text became more widespread, the prospect of natural language understanding has re-emerged as a plausible goal. Natural language processing is a field of understanding human language using computers. It involves the analysis of large volumes of natural language data, using computers to glean meaning and value for consumption in real-world applications. While NLP has been around since the 50s of the last century, there has been tremendous growth in practical applications in the area due to recent advances in machine learning and deep learning. In this video, we'll describe some language understanding technologies to give you a sense of the interesting challenges that are waiting for you. One of the most popular NLP technologies today is machine translation, the task of translating a piece of text from one language to another. For a long time, machine translation has been the holy grail of language understanding, ultimately seeking to provide high-quality, idiomatic translation between any pairs of languages. Its roots go back to the early days of the Cold War, when the promise of automatic translation led to substantial government sponsorship, and with it the genesis of NLP itself. Today, practical translation systems exist for particular pairs of languages, and some are integrated into web search engines. However, these systems have some serious shortcomings, which are starkly revealed by translating a sentence back and forth between a pair of languages. Machine translation is difficult because a given word could have several possible translations, depending on its meaning, and because word order must be changed in keeping with the grammatical structure of the target language. Today, these difficulties are being faced by collecting massive quantities of parallel texts from news and government websites that publish documents in 2 or more languages. The sentiment in a sentence or text reflects the overall positive, negative, or neutral opinion or thought of a person who produces or consumes it. It indicates whether a person is happy, unhappy, or neutral about the subject or context that describes the text. It can be quantified as a discrete value, such as 1 for happy, -1 for unhappy, and 0 for neutral. Or it can be quantified on a continuous scale of values from 0 to 1. Sentiment analysis, therefore, is the process of deriving this value from a piece of text that can be obtained from different data sources, such as social networks, product reviews, news articles, and so on. One real-world application of sentiment analysis is in social network data to derive actionable insights, such as consumer satisfaction, product or brand popularity, fashion trends, and so on. It also provides the basis for many prediction-based applications, such as making political forecasts about the elections or similar. Natural language generation is a software process where structured data is transformed into natural conversational language for output to the user. In other words, structured data is presented in an unstructured manner to the user. Think of natural language generation as an inverse of natural language understanding. With natural language understanding, we are taking the unstructured conversational input from the user, natural language, and structuring it for our software process. With natural language generation, we are taking structured data from backend and state machines and turning this into unstructured data, conversational outputs in human language. In the history of artificial intelligence, the chief measure of intelligence has been a linguistic one, namely the Turing test. Can a dialogue system responding to a user's text input perform so naturally that we cannot distinguish it from a human-generated response? In contrast, today's commercial dialogue systems are very limited, but still perform useful functions in narrowly defined domains. In the big data era, there has been an explosion in the amount of text data from a variety of sources. This volume of text is an inestimable source of information and knowledge which needs to be effectively summarized to be useful. This increasing availability of documents has demanded exhaustive research in the NLP area for automatic text summarization. Automatic text summarization is a task of producing a concise and fluent summary without any human help, while preserving the meaning of the original text document. It's very challenging, because when we as humans summarize a piece of text, we usually read it entirely to develop our understanding and then write a summary highlighting its main points. Since computers lack human knowledge and language capability, it makes automatic text summarization a very difficult and non-trivial task. SQL query generation, or semantic parsing, helps to convert a natural language into SQL queries in order to query a database. A deeper kind of language understanding is to work out who did what to whom. For example, to detect the subjects and objects of verbs. You learn to do this in elementary school, but it's harder than you might think. In the sentence, "The thief stole the paintings," it is easy to tell who performed the stealing action. Consider 3 possibilities following sentences and try to determine what was sold, caught, and found. One case is ambiguous. First, the thief stole the paintings. They were subsequently sold. Second, the thief stole the paintings. They were subsequently caught. And third, the thief stole the paintings. They were subsequently found. In all of these examples, working out the sense of a word, the subject of a verb, and the antecedent of a pronoun are steps in establishing the meaning of a sentence, things we would expect a language understanding system to be able to do. In word sense disambiguation, we want to work out which sense of a word was intended in a given context. Consider the ambiguous words serve and dish. Serve means to help with food or drink, to hold an office, or to put ball into play. Dish means a plate, a course of a meal, a communication device. In a sentence containing the phrase, "he served dish," you can detect that both serve and dish are being used with a food meanings. It's unlikely that the topic of discussion shifted from sports to crockery in the space of 3 words. This would force you to invent bizarre images. Humans automatically disambiguate words using context, exploiting the simple fact that nearby words have closely related meanings, which is a challenging task for a machine. Named entity recognition is a type of text annotation task. In named entity recognition, words or tokens in a piece of text are labeled or annotated into categories, such as organizations, locations, people, and so on. In effect, named entity recognition converts unstructured text data into structured data that can be later used for further analysis. Textual entailment predicts whether the facts in different texts are the same. Despite the research-led advances, natural language systems that have been deployed for real-world applications still cannot perform common-sense reasoning or draw on world knowledge in a general and robust manner. We can wait for these difficult artificial intelligence problems to be solved, but in the meantime, it is necessary to live with some limitations on the reasoning and knowledge capabilities of natural language systems. Accordingly, right from the beginning, an important goal of NLP research has been to make progress on the difficult task of building technologies that understand language, using superficial yet powerful techniques instead of unrestricted knowledge and reasoning capabilities.